And now we're going to do the same analysis, but in this case we're going to use an adaptation of the IEC 61511 part 3 method C, and we're going to apply the risk graph to the same scenario. So here let's have the same scenario. So in this case we looked at the likelihoods, and these likelihoods are a representation of the same likelihoods as they were defined in your risk metrics originally, right? Again, we're supposed to have the HACCP analysis done before we start doing this methodology, just the same way as for LOPA, layer protection analysis. We need the HACCP to have identify all the hazards, and then from those hazards we picked the ones that are complex or that have high risk, or another criteria chose by the company. So in this case we have um, very qualitative definition of these likelihoods. W1 would be very low, W2 will be low, W3 will be relatively high. In this case for us, maybe W3, and we'll then start making decisions and asking questions, and this is very qualitative method. There's no mathematics involved here, just decisions according to some description of words or linguistics that we call. What does slight injury means? What does serious or injury or death means? And then we try to classify them and have assigned conditions, for example, C1, C2, or assign consequences with respect to safety, right? So what does the probability of avoidance means? Uh, one is P1 for possible, P2 for not likely. For there's a little bit of help sometimes for describing what possible means or what not possible means. So possibility of P1, that means that it is possible to escape. Escape routes are well marked. There are alarms and horn beacons. There are gas and fire detectors. Personnel have been through accident scenario training. So you might consider that you can choose P1 if this is true. In order to choose P2, that is not possible to avoid the hazard, then you go through, for example, there is no time to escape, or the escape routes not passable or under specific conditions, or the danger is not recognized, and so on. So that can give you an idea when to choose or to make the decision with respect to P1 or P2. And the same thing goes for F1 and F2. So F1 would be rare and F2 will be frequent. But what does that mean? We also need a little bit of input or guidance from some type of explanation. So in order to be able for the team to decide whether which choice do we pick, F1 or F2, P1 or P2, right? So it's all very qualitative at this stage. And we have to say that this method, the way that that works is by not having any safeguards at all in there. So this will be used. This method is dependent on a calibrated risk graph. So this is the risk graph that you see there that represents your risk metrics, but in this case the risk metrics have certain numbers inside. So it's a snapshot, not the total risk metric, but a portion of your risk metrics that contains numbers, and those numbers are with respect to SIL levels, so SIL safety integrity levels for the safety implemented function. So we start looking for what is that safety implemented function SIL level, and then at the end when we go through all the risk categories, and we will have our highest requirement for a safety implemented function, which will be given by that number at the inside there, according to when we answer the questions about how frequent, what would be what is the worst consequence, whether the personnel is exposed to that hazard, and whether you can escape it or not. And then we'll end up with a number there. So for example, in this case we might say 2 W2 between 1 in 10 years and 1 per year. So we saw the description there that we were talking about several problems. So I assume that they decided to go back and work on the useful life of the equipment, and they say this thing should not happen more often than 1 in 10 years. So that's why they said, okay, the frequency of this should be a W2. Then later on, what would be the consequence or the safety consequence? This is for health and safety, right? So C2, we saw there that one person could have lost his life, so serious injuries or one death. And so here's the description of what that means. So this is a decision for C2, so W2 with the likelihood, and C2 possible loss of one life. Then F1, it is rare, so personnel being in the close proximity to the incident for a period of greater than 10% of the shift. So in this case was judged that it was F1, it is rare. So the exposure is rare, so meaning that the trucker, that people that come inside the park, it is not that frequent. So, and then P2, whether it was possible to escape or not, or to avoid the hazard once it presented itself. So it was not likely. So no time to react to a situation. And that gave safety integrity level 1 required for a safety implemented function in this case, right? So now for assets, the one that we were looking at before was a calibrated risk graph with respect to having a loss of life, with respect to safety, one people, right? So in this case, you can expect that these numbers here represent certain tolerability, right? The same way that we were talking about with the methodology for LOPA. But now it is very important to calibrate your risk graph according to the type of risk that is being analyzed. If it is health and safety, you will have a different risk calibration with numbers inside 1, 2, 3, 4 than if you had assets. So this represents how tolerable for that company it is to this situation to lose an asset in this case. So you can see in this case that we don't have any more the C or the consequence. Now we have the asset consequence, right? So W2 doesn't change, it's the same as before. And then in this case, it was judged by the team that a loss, major operational upset or equipment damage between 5 million and 50 million. So in this case, the entrance point here was L3. Then again, P2, possibility of avoidance, the asset cannot escape, the asset has to stay there. So, and with respect to the F1, the asset is there all the time, right? So that's why there's no F in there. So in that case, W2, we gave us a SIL 3 requirement for a safety implemented function. So we saw there before for health and safety, we had requirements for a SIL 1 for a safety implemented function with a safety integrity level 1. And now for with respect to asset, is telling us that the tolerance for this company, it is very low and requires a higher SIL level. Sometimes when you find this results in here, you question a little bit the calibration of those risk graphs, right? Or those graphs that you have in there, and then you go back and you make sure that really the calibration is done correctly. So we go finally to environment risk in there. So what are the consequences of an environmental hazard or consequence, unwanted event with respect to environment? Again, the frequency or the likelihood doesn't change. It's W2, that's the one that we picked before. Then we have, it was judged an environmental few weeks cleanup release with moderate impact on the environment. P2 as before, not possible to avoid if it happens. So then we end up with a SIL 2. So we had a SIL 1 for health and safety, we have a SIL 3 for asset, and we have a SIL 2 for environment. In this case, according to the 3, we have that one driving case, which is the asset case. and that asset analysis require us to have safety integrity level 3 for a safety implemented function if we in order to cover that risk. So SafeGuard profiler, how do you put that in there? So we have here in a safety implemented function loop, right? And then we have in the SIL determination page, we choose, we have again the likelihood, the safety, and then for the environment and an asset. So what is the likelihood? It was 2, right? So set the demand rate for all graphs and safety, asset, and environment. So remember the W2 didn't change in the 3 analysis that we made. So again, we go to, for the health and safety part, we have consequence, possibility of avoidance, and the frequency of exposure of the person. So in this case, we chose in there, we set the consequence rating for the safety. It was frequent, and it was not likely to escape. And in this case, was a SIL 3. Well, this is a little bit different from what I did before, because this C3, I think it was different. So now we can start adding our safeguards that were there. For example, the pressure safety valve, right? So, and then we can subtract from that 2 that we got before, SIL 2, or SIL 3, SIL 2, SIL 1, right? So we chose 2 of them. So that's the process in there. So functional SIL level will be the highest of the 3, right? If we haven't, here was not finished the environmental of the asset, and we only went through the safety one, right? So apply the IPLs. There are 2 IPLs that could be used, and each one is worth 1 credit or 10 risk reduction. So we went from a SIL 3. Here you can see SIL 3, and we take 2. So SIL 3, SIL 2, and then SIL 1. So which equals the final target SIL after applying all the safeguards. So for example, a SIL 1 was required. So that's the way that the 2 methodologies that are available in SafeGuard Profiler, layer protection analysis and risk graph also. So now we're going to go into this section, getting to know SafeGuard Profiler. So loop linking, we already know how, by looking at the videos, we know how to link, and we saw the graphic representations of linking a SIF loop to a LOPA loop. And now the next thing that we're going to look at is how to link a safety implemented function to a safety implemented function. What that means is that we can link the sensor to a final element in another loop, in another safety implemented function loop. And I'll show you why it's sometimes useful to have this feature in here. We will talk about the safety requirement specifications for the safety implemented functions. We'll talk about contingency planning at risk exposure. So today we don't do this too much. This is done at the production process side of things, right? This is not done with respect to what would you do if you lose a safeguard, what would you do if your risk increases because you lost some safeguard. Do you have any contingency plan for that in order to supply that risk reduction that you were counting on, or that was there before because it was not tolerable? So if you lose that safeguard, so a situation that is not tolerable for the company, then it becomes an issue, and then you have to work on it. So where would you do contingency planning? You would do it at the same time that you're doing your layer protection analysis. You will spend a little bit of time, more time on the session, say what happens if we lose this safeguard, what happens if we lose that safeguard. Then we'll talk about reports and also videos about reports. And by this time you already know how to import and export projects. Maybe you already emailed someone with a project, and also there are some videos uploaded also that you can watch many times with respect to how you import and export a project.